Okay, today we're going to do a circuit over factoring by grouping. So this circuit is a lot like yesterday's circuit, but today it's all going to be by grouping. And like yesterday's, you're going to find one of the factors as your answer. Okay, you're going to look for that answer. It'll be one of your two binomial factors. There's one problem that is not binomial factors, and I'm going to do that one with you guys so that all of your problems will be like ones we've done before. Remember, as you go through, you start with number 1, mark the second one, say it's this one, we'll put a 2 here. Okay, it's not, but if it were, we would write 2, solve this one, find the answer, write 3 on that one. And reminder, as you're doing your work, I'm looking for the correct numbers being here, and your work that leads you to the answer that you're going to choose to go to the next problem. Okay, so let's start with the first one, just to review grouping, and then we will do 2 other ones, and then I'll leave the rest for you. There are 16 of these, but they're pretty straightforward. Okay, so we're going to review grouping, and we're going to just assign groups. So we have 4 terms, which tells us that we can do grouping. And I'm just going to group the first 2 and the second pair together. So remember, we have to look at what do these 2 terms have in common. Okay, what do 2x squared and 2ax have in common? If you have to, write them out. 2x squared, 2ax. Okay, 2x squared is 2 times x, 2ax is just 2ax, and you circle what they have in common. So this first one, your GCF is 2x. What is left, my 2x squared had an x, and my 2ax is left with an a, so x plus a. Alright, plus, what do my next 2 things have in common? It's pretty clear. The only thing they have in common is a 7. And then, what is left when we take the 7 away from 7x? Just the x. What's left when we take the 7 away from the 7a? Just a. Okay, I'm trying. Alright, so then we take the outsides and put them together, and the insides and put them together. So we end up with 2x plus 7 as our binomial for the outsides, and these match, so we can write them down identically. Remember, you're working for this to be identical even with signs, so you may have to remember to take a negative if these are both negative, so that this will match this binomial. So we're looking for either 2x plus 7 or x plus a. So let's look here. We have an x plus a right here, so this is going to be problem number 2. Okay, starting fresh. Group things together. What do they have in common? XA and X, they both have an X in common. So if we take X from XA, we're just left with A. If we take X from X, there's nothing left, but you have to put that placeholder of 1 in there. Alright, plus, what do we have here in common? They both have a 2. So then 2a divided by 2 leaves the a. 2 over 2 is everything, but it leaves us this factor of 1. These match, so we can write the outside terms and that matching inside term to get x plus 2 times a minus x plus 2 times a plus 1. Okay, so I want to see your answers. X plus 2, a plus 1. We have x plus 1 up here, but that's not the same. This is a 2-pager, so you can look on the back. X plus 2, this is minus, so it's not that one. A plus 1. So this, when you get going here in a minute, that will be the next problem you do, number 3. And if you're doing this from the electronic copy, you can just do them in order. So write down the problem for 1, solve it. Write down the problem for 2, right here on your paper, label it number 2, solve it, then you'll write down the third problem you're going to solve and solve it. So if you make a mistake, it's going to be a little harder to fix as far as the order of the numbers go, but you don't have to print out the circuit. It may be a little easier to manage that way, but you can still do this on loose paper. Okay, so this is where you'll go when you get started when the video's over. The last one I want to do with you, this will actually be number 16, so you can mark that. But this has 1, 2, 3, 4, 5, 6 terms. So instead of 4, we can still group them into 2 groups, but they're each going to have 3 terms. So if we look at this first one, we've got x squared plus ax plus 3x. All of those have an x. So what happens if we steal an x from each piece? X times what is x squared? That's just x. X times what is ax? That'll be a. And x times what is 3x? Plus 3. Okay, hopefully when we do this next one it'll be the same. What do these all have in common? 2x plus 2a plus 6. All of those, there's no variables because this doesn't have any, but 6 is 2 times 3, so we can take a 2 out of everything. So 2 times what is 2x? That's going to be x. 2 times what is 2a? That's going to be a. 2 times what is 6? That's going to be 3. Your resulting polynomials here match. So you just take out what's in front. So this is going to be x plus 2. We have an x outside and a 2 times what we pulled, what the result from when we pulled those numbers out. So x plus a plus 3. Okay, so that one's a little more complex. It had some more terms in it, and we hadn't seen it before, so I wanted to do it for you. The rest of them are all like problems that we've done before. And you can check here. Remember, the last problem will always lead to number 1. We had a trinomial there, a plus x plus 3, which is this right here. Okay, so there are 12 problems left for you to do. No, maybe 13. But it's all by grouping, and you're all going to end up looking something like these with the binomials. 2 terms times 2 terms, 2 terms times 2 terms. Just as a reminder, when you see something like this down here in the bottom of this column, if these are both negative, remember you want to take a negative out. So this will end up being parentheses minus some number times your parentheses. That way you'll make sure that these match. Okay? Alright, good luck, and if you have any questions, send me a message in the assignment or an email.